Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at using the substitution method to solve simultaneous equations. Now, simultaneous means at the same time. We will look at taking two equations and solving them at the same time. See, this equation here has infinitely many solutions. For example, if x equals 3, y equals 1. That is a solution to this equation. Similarly, this here has infinitely many solutions. An example of a solution would be 11, 4. X equals 11, y equals 4 is a solution to this equation because if you substitute those values into the equation, it makes it true. Turns out though, there is one solution to this equation that is also a solution to this equation. That's what we're doing when we're solving simultaneous equations. We're finding the solution to this that at the same time is a solution to this. So how do we use the substitution method to do it? Well, what we do is we substitute one equation into the other. Okay, so which one do we substitute? We substitute whichever equation has y or x as the subject. This equation here has y as the subject because y is by itself. So I'm going to take this top equation and substitute it into the bottom equation. So what does that mean? Well, it means I'm going to take my bottom equation here, which is 3x minus 4y equals 16. And everywhere I see a y, I'm going to replace it with 7 minus 2x. Now, undoubtedly, the most common error made here is not putting brackets. I need to put brackets around what I've just substituted. See, now I have one equation with one variable, and we know how to solve them. What I'm going to do is expand the brackets, so negative 4 times 7, and then negative 4 times negative 2. Now we're going to collect like terms. 3x plus 8x is 11x. So I got 11x minus 28 equals 16. You know how to solve from here. We just add 28 to both sides, divide by 11. We get x equals 4. But we're not done yet. We need to find the y value. To do that, we just substitute our answer into either equation is fine. It's going to be a lot easier, however, to substitute into this equation. So if x equals 4, y equals 7 minus 2 times 4. So that just equals minus 1. The solution here we write as a point 4 minus 1. The reason we write it as a point, this here y equals 7 minus 2x is a line. It's a line that would look like this green one here. 3x minus 4y equals 16. I can graph it as a line. It'd look like this blue line here. What we're finding when we are solving simultaneous equations is their point of intersection there. So that point where the lines hit each other would be 4, negative 1. X equals 4, y equals negative 1. We just don't want to always draw the graphs of these two and find their points of intersection, because apart from the fact that that takes a while, it won't allow us to see the solution when, you know, x equals a third, y equals 4/5 or something like that. We have to be super accurate, which we can't always be with our hands. So that's why we use these algebraic rather than graphical methods. All right, let's now look at solving a worded problem. So let's try this question here. The length of a rectangle is 3 more than double its width. If the perimeter is 54 centimeters, calculate the dimensions of the rectangle. So how do I know that this is a problem for which I would use simultaneous equations? Well, we need to find two quantities at the same time. We're asked for the dimensions of the rectangle. So that means we need to find the width and also the length. So whenever you're finding two quantities at the same time, think simultaneous equations. So as is usual when solving word problems in maths, we start by defining our variables. So I'll just let x be the width and y be the length. It doesn't matter which you let be x and which you let be y. So after defining our variables, our next step is to form two equations. We form those from the two bits of information given. The first bit of information tells us that the length is 3 more than double its width. So let's turn that into an equation. Length equals double the width plus 3. Now, we can't solve this equation by itself. It'd have infinitely many solutions. We need a second equation, which we get from the second bit of information. Here, that information is that the perimeter is 54 centimeters. Now, we know that in any rectangle, the perimeter is simply twice the width plus twice the length. Now we have two equations. We will solve them using the substitution method. So we take the equation that has y or x as the subject, in this case, that's this one, and we substitute it into the second equation. That means I take my second equation and I replace y with, in this case, 2x plus 3. Once again, remember to put brackets around the expression you substitute. So now I have one equation with one variable. I expand the brackets, so I get 2x plus 4x plus 6 equals 54. We collect like terms, so we get 6x plus 6 equals 54. Now you know how to solve it from here. Subtract 6, divide by 6, you get x equals 8. So the width here is 8. We're not done because we haven't found the length. To find y, which is the length, we substitute our answer into either of these equations. Into which one we substitute doesn't matter. So here the length y is just simply going to be 2 times x plus 3. It's going to be 19. So the dimensions are 8 centimeters by 19 centimeters, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.